welcome back. Today we're talking about Chapter 2, which is all about scientific notation, which you may have learned of in science. I think most of you did. And today we're talking about understanding scientific notation. So go ahead and pause and do your warm-up. And then we'll start our actual lesson. So if I look at a number, like this, 300 million, we write this in scientific notation because when we have a very large number or a very small number, we can put it in a more manageable piece, just like how we did with exponents in the last chapter. So that sentence is all typed out for you in the guided notes that I gave you the other day. So if I look at this, I can write 300 million in scientific notation by saying there's 1, 2, 3, 4, 5, 6, 7, 8 spots. So this is equal to 3 times 10 to the 8th power. So the number in front here, this is called the coefficient. Okay. And then this 10 is the base, which you guys already learned, and that's what you did in your warm-up today. And the 8 is called the exponent, which again, that's all the stuff that we learned in the last chapter, so nothing brand new there. Okay. The biggest thing in scientific notation, the coefficient has to be a number between 1 and 9. Can't be 0, it can't be 10 or above, okay? It can be a negative number, that's okay. But the actual number without the sign, this number here, has to be between 1 and 9. Okay. So we're going to talk about a couple examples here, and we're just going to identify if they are properly written in scientific notation or not. So I kind of had it rewritten earlier because I accidentally messed up the video. So we'll go through these. And these are typed for you already in your sheet. So a horse chestnut has a diameter of 2 times 10 to the 0 centimeters. And this number here, is it properly written in scientific notation? Which you probably already saw my answer, and that's yes, because my coefficient is between 1 and 9, and it's 10 to some sort of power. Okay, so that one's good. If I look at this one, so it says Neptune is about 4.488 times 10 to the 9th kilometers from the sun. So that is true. This is also in scientific notation. My number in front here of my decimal is between 1 and 9. That's 4 there in case you can't tell. There was a little oops there. And then it's 10 to some power. So that is totally good there. And then my last one here is kind of funky. So it says the approximate wavelength of an infrared light is 0.01 times 10 to the negative 5. And this is a time sign here. I accidentally had my red line over it before. And again, this is not properly written in scientific notation because 0.01 is not a number between 1 and 9. Okay, positive or negative. So this is no, because the coefficient is not written as a number between 1 and 9. Okay, whether it's positive or negative, that doesn't matter. So be careful. This is not written in proper scientific notation. Okay. Again, you should feel free to pause this video anytime I'm going a little fast. I don't have to write because I had it written previously, so that's why I can go a little faster. So the last one, a football field is 10 times 10 to the 1 yards long. And again, this number here is not written in proper scientific notation because the number in front, the coefficient, is not a number between 1 and 9. 10 does not follow that. Okay. So now we're going to go through some examples of writing numbers in scientific notation here. Let's flip back to this page here. So I want to write a number in scientific notation. Sorry, that's a little small there, but. So my example A, I'm looking at 427.7. So there's several ways you can think about changing a standard form number to write it as a scientific notation. You may have learned this in science already, and that's fine. Do it however you see fit in science. One way to do it is I can think, okay, I want to move my decimal so that way the number in front, which would be 4, is between 1 and 9. So 4 is the number, because if I move it 1 decimal, that's 42. Another decimal, that's 4. So I want it between 1 and 9. So I definitely have to move my decimal place this direction 2 places. Okay. So if I think about it, I'm rewriting that as 4.277. So if I ever wanted to go back to my original number, I'm moving it 2 places to the right. So that means I'm moving it, I would need to multiply it by 100 to move that decimal place over. Well, 100, if I write it in exponential form, which we learned how to do last week, is 10 squared, because 100 is 10 times 10. Okay. So that's one way to write it in scientific notation. Another way that I think of it is if I look at 427.7, I'm moving it 2 places. Okay, so I'm still doing that, but I'm moving it a bigger number to make it smaller. So I need a positive exponent, and since I moved it 2 places, that exponent is 2, and then I can write it as 4.277. So when I make a bigger number smaller, to get it back to its original form, I want to make it bigger so I know I have a positive exponent. Okay, and that's going to take some practice to really get down 100%. Okay, so let's look at a different example here. So example B here, I have 0.007. Okay. And again, I like to do it the second way here. This is my way to do it. So I'll do that way first. Again, I need a number between 1 and 9 that's in front of my decimal place. So I move it 1 place, that's still going to have a 0 in front. 2 places, that's still a 0 in front. 3 places, now I have a 7. So I'm moving it 3 decimal places this way. So I'm making my number smaller. Okay, or I'm sorry, I took a small number and made it into a bigger number. So that means I have a negative exponent. Okay, so then it's going to be 10 to the negative 3, because if I were to make it big again, I'd move it 3 towards the negative direction. So you can see that, okay? So it'd be 7 times 10 to the negative 3. Again, that might be a little more complicated for you. So if you like it the first way from before. Okay. I'm still moving it 3 decimal places this direction. Okay, but then I can think of that as really, if I start with 7, I would really have to divide that by 1,000 to get that place value, because this was in the thousandths place. Well, I know 1,000 is really 10 times 10 times 10, which is 10 cubed. And because I can have negative exponents in scientific notation, this is the only time it's allowable. So I can move this back up, and if I move it up from a positive, it becomes negative. So it's like flipping our negative exponents that we learned about last week. Okay. So either way, you'll get the same answer. You can see both of them are 7 times 10 to the negative 3, 7 times 10 to the negative 3. Okay. So let's do 2 more examples with that. So another one, we'll call this C, 856.2, and I'm still writing this in scientific notation. I'm moving it 2 to the left. So I'm making a bigger number smaller. So that means I want a positive exponent because I started off bigger. And since I moved 2 places, it's 2 times 8.562. Oops, sorry, that dot isn't very clear. Okay. And again, if you prefer to think of it as, oops, I start with the decimal here and I move it 1, 2 spots. That's like saying 8.562 times 100 to get back to that number. So 8.562 times 10 squared. Okay. And one last example for you. So if you want to kind of pause it and try it on your own, see if you can get it, that would be good. So again, I see that I'm making a smaller number bigger, and I'm moving it 2 places to the right. So since I'm making, it's starting as a small number, I know I want a negative exponent. So this is going to be 6 times 10 to the negative 2. And if you prefer it this other way, I can think of I'm moving it over 2. So that really means I'm dividing it by 100, which is really 1 over 10 squared. And since it's in the denominator, I can have negative exponents here, so it's 10 to the negative 2. Again, I don't care which way you show your work on that. You just need to show me that you know how to do it. Okay. So now I kind of want to go backwards. If I give you a number in standard form, I'm sorry, if I give you a number in scientific notation, I want you to write it in standard form. Okay? So if I look at the number 7.1 times 10 cubed, whenever I see a positive number, I move it in the, make it a bigger number. So 7.1. So 1, 2, 3 decimal places. So this is where my new decimal is. And wherever I see these blank bumps, I'm going to fill in with 0. So this would be 7,100. Another example here would be, I have 8.12 times 10 to the negative 3. It's negative, so I'm making the number smaller. So I need to move it 1, 2, 3 spots. This is my new decimal point. Fill in these bumps with zeros. So I get 0.00812. And this would be in standard form. So these two numbers are in standard form. Okay, so you should be able to go back and forth between the two. So let me show you your exit slip. I have this written from the previous time I had to do this video. So there's your exit slip. And then your homework is page 66, numbers 1 through 11 odd. And you can pause it here and finish the exit slip. You're going to write 3,150,000 in scientific notation and 3.2635 times 10 to the 5th in standard form. Okay. Have a great day. We'll see you tomorrow. Bye.